It's great to be here. Thank you all for coming. And as Begum said, I'm going to be talking to you about data science and why pursuing this path is going to take you further than Python for SEO. We're going to have fun talking about that, or at least I will. So a little bit about me. I work at the intersection of these fields. I don't properly belong into any one of them, somewhere in the middle. So I get to play around these things. I am creator of a Python package called advertools. As we said, it's been downloaded about 4 million times, not people. And I'll show you a bit about how it works and what it does and what you can do with it. I've also authored a book about building interactive data apps and dashboards, also in a Python framework called Dash. So, and also I have a workshop tomorrow. The workshop will be this presentation. So if the stuff here is interesting, you can come tomorrow and actually do the same stuff. You write the same code, and you will implement the exact same things that you're going to see here. So when I started in this field and got excited about sharing stuff about this, I realized we have a certain keyword problem. And let me read this quote for you quickly together, so to tell you why this might be an issue. So when some field is just getting started and you don't really understand it very well, it is very easy to confuse the essence of what you're doing with the tools that you are using. So we're confusing the tool with the activity that we are using. And let me tell you why this might be an issue. So imagine I come to you one day and I say, hey, I created a great website, okay? And I'm getting 100,000 visitors per month or per day or whatever. And then you ask me how you did this, and I say, I did it with HTML. Now it's true, every website is built with HTML, but it's clearly misleading because yes, the main tool of SEO is HTML, but there's all these skills over here that I'm leaving out and I'm not telling you about. And then you go and learn HTML and you come back and you tell me my rankings are not changing. Well, it's not just about HTML. So the same thing happens here with Python. I created this great analysis, I ran this workflow, and you asked me, how did you do it? I did it with Python. It is as misleading as saying I did it with HTML, because these are all the other skills that are really needed to be able to use Python. And it's not just about the tool, it's about what we do with it and the skills behind that. So there was also another counter movement, let's say, of a bunch of people who insist to prove that you don't need Python to do SEO, and they both are quite entertaining views. Anyways, so let's get started with some data skills and what we do in the trenches, and see how this might relate to you. So we're going to start with the minimum viable knowledge that you will need to get started, okay? And this is going to be just 3 concepts. You're not going to learn anything new. These are concepts that you already know. We're just going to review them together. And 1 file format that we're going to be talking about. Okay? So let's start by reviewing how the concept of variables and how spreadsheets work. So you go into a code cell in Excel or any spreadsheet. You start typing code. And you hit enter. And then Excel computes the result of that code and displays it in that cell. Okay? So for example, here the source code here is =10 plus 5, and the result of this code is 15. Okay? So as a side effect of running this code, Excel creates something for me. It gives a name for this value. It calls it B2. Okay? And this is the variable. And the variable is a name that refers to a certain value. And as you all know, I can say this is equal to B2 plus 5 plus 10, whatever B2 is. I don't want to know what B2 is. I don't want to compute it myself. I just want to say this plus 5 plus 10, okay? So 1 is variable. The second one is functions, which you all know. You use a function by using the equal sign, and you type in the name of the function, and you put parentheses, and within the parentheses you put the parameters separated by commas, okay? Whatever these commas are. So the important thing here is that once you know how to use 1 function in Excel, you can use any other function. You don't need more Excel knowledge, you need more topical knowledge, whether it's math, whether it's statistics, economics, or anything like that. And you'll see that it works the same way with with Python and other programming languages. The third concept, which you already know, is the right click. So the right click is also a menu of functions. It's a contextual functions. So, and it depends on the type of the object. So if I right click on an image, I get a certain set of functions that I can do with an image because it's an image. If I right click on a piece of text, I get a different set of functions or commands that I can run because it's a different type of object. So over here we have an object called daily impressions, and we trigger the right-click functionality in Python using the dot notation. You click, you type in a dot, and you hit the tab button, and here you can see all the functions that are available based on this object type, okay? So variables, functions, and right-click, which you already know already. So we also have a file format that I want to talk about, which is the Jupyter Notebook. So as we all know, there's something called a file format, which is independent from all the applications that can operate on this file format. So for example, we have CSV, which is a text file that has nothing to do with Excel or Google Drive or anything else. Anyone can create an application that works with and operates on CSV. So as long as you and I work with CSV, you're free to use whichever application you want. And another result is that once you learn Excel, it's easy to move to something else that is similar as a spreadsheet, okay? So the Jupyter Notebook format is something like this, but we don't work with the actual text. We have applications, as you can see here, that can read and write and operate on Jupyter Notebook, okay? So this is the minimum viable knowledge that we need to start working with Python. So I'll show you a bit about advertools, which is a Python package. So imagine you have someone, when you start Excel, you have, let's say, 100 functions that are available to you by default. So imagine someone created 50 additional functions, they put them in a certain format, and you can install them from something like an app store, and all of a sudden your Excel has 50 new functions. This is what a Python package actually is. So you install it with this command, and once you install it, you can import it, and then you can use the dot notation to see what functions you have, and you can get started with using it right away. So let's start with one of the first functions. So this code cell here, this contains the three concepts that we talked about. First, we have a variable assignment, so sitemap equals something, so name equals value, but instead of meaningless stuff that spreadsheets give us, like A1, A2, B1, B2, we can put the name that we want. So I'm going to call it sitemap. So later on when I read it, or when you read it, you know what this is. And then we have the dot notation and the name of a function, sitemap to df, and then with parentheses, we give it an argument for that parameter, okay? So this takes a robots.txt file, extracts all the sitemaps, and puts them in a data frame. A data frame is just a table. I'm not trying to be fancy here, but that's just the name of this. It's a table, but that's the name used in data science usually, okay? So now I have something called sitemap, and it looks like this, okay? These are the columns, the XML converted to a table. So I can use, whoops. I can't use. What did I do? Back, forth, not working. Okay. Yes, okay. So this is another function called URL structure, which takes a list of URLs and creates this visualization for us, okay? So this is about 300,000 URLs of the NBA.com website. And you can immediately, as you can see with one line of code, get an insight about how this whole website is structured. As you can see, it's mainly about teams. That's the full thing. And you can see each team and how many URLs it has and what's the percentage it forms of the total. You can also click into one of these boxes and see how this subfolder in that domain is split itself and how many URLs we have under news, video, and so on. Another thing we can do is we can take the last mod column, from this sitemap, and we can use the ECDF function. And this shows us very quickly the publishing activity of this website, only for the URLs that have the last mod tag. So as you can see here, we have a huge number of URLs that have been last modified somewhere before 2021. It's unlikely that they created all these URLs in one day. It's most likely that they've made a bulk update to a lot of more than 4,000, 5,000 URLs. We can also see here that there's a gap between 2021 and 2022, which means there hasn't been much publishing activity. Then they became stable, and then they went up. And for every URL here, you can mouse over the dot, and you can see which URL was last modified and which on which date. So this is as you can see here, we have 300,000. Okay, was a short video. It's not working. No problem. So we did all this analysis with 4 lines of code. We got 300,000 URLs. We split them. We visualized them in an interactive way, and we saw the publishing activity. And it only cost us 4 lines of code. So I would like to also now show you another way of doing this. Okay, so I have an app like this which doesn't require code. You just input the URL over here, and you get the same 2 charts interactively, and so on. Okay, so what's the difference here, and how does it influence us? So the first one is doing coding in a Jupyter Notebook, and the second approach is creating an application that requires no code, that does what we showed just a minute ago. The functionality is identical. Okay. Here we have 4 lines of code: 1 to install, and 1 to get the sitemap, URL structure, and publishing trends. 4 lines of code. If you want to create it as an application, you need 150 lines of code. And you have to work with Linux, a web server gateway interface, the app code, and all this complexity. So what I would like to distinguish here for everyone is the 2 concepts of programming versus software development. Okay? So many people think when you start getting into Python, which is a programming language, you want to become a software developer. No. Or maybe you want to, that's fine, but that's not the great news. The great news is here, which is, as you saw, with 4 lines of code, you can do all these great things, very easy. It doesn't require any knowledge. It requires stuff that you already know. You know how to run functions in Excel. You can run them in Python. You just need to know about these functions. So that's a very important distinction, I think, that people who start this should know, is the difference between this programming, where you just run these commands and get the outputs and run all kinds of data workflows for yourself and for your team, versus becoming a software developer who builds these complicated apps and gets into the details of Python, in which case Python becomes a real snake, not just a programming language. So not advisable. This one is more advisable. So quick question, how many of you know Excel? Okay. How many of you know more than 10% of Excel's features? Okay, almost, not much less. Does anyone here build Excel plugins? No. Okay, so this is the kind of relationship you'd want to build with Python. You're comfortable saying, I know Excel, but at the same time, I don't use more than 10% of Excel, which means you're an Excel user, right? So the idea here is you want to become a Python user, but not a developer. You don't care about all those details of how the classes are created and none of that. You just want to use it, and you could become very advanced as a user and create great results without becoming a developer. Okay? So how much Python do you need to learn data science is a natural question. My answer is, how much HTML do you need to learn SEO? Pretty much the same thing. So the difference between the HTML that you know and the HTML that the web developer knows and uses is quite different. You know HTML. You know how to create a basic page. You can put bold, H1, H2, whatever. You can use it very well, but you don't necessarily need to build those complicated apps and do payment gateways and all this stuff. So that, again, that's the difference between using the programming language and building and developing using that language. Okay, the next logical thing is what you're probably wondering is how does this fit and relate to AI and LLMs? So I think that data science is much more relevant, approachable, and useful with LLMs. So relevance, why is that better? Well, because with your data skills, you can start running prompts in bulk. You don't have to just take an article, do something with it, take another article and do something with it. With basic data skills, and I'll show you an example, you can run a prompt template, and for a bunch of inputs like URLs or images or titles or whatever you want, you just plug in certain values and get work done on a very large scale. As I mentioned, the minimum viable knowledge is way less now because of LLMs. You don't need to memorize all the functions, all the libraries, all the tools. There's a dot, there's a comma, like we used to do in the Stone Ages, like 2 years ago. The LLMs can write the code for you and can explain it to you, and all these things. It can help you discover what you can do with it. It's more useful because now with your data skills, you can structure your inputs much more than before, instead of just throwing some data at the LLM, and you can minimize the chances of hallucination, okay? And we'll do an example right now. So before getting to an example, let me just distinguish between what traditional software does and LLMs do in terms of their capabilities. So traditional software is more deterministic. You give it an input, it gives you an output. It's like a calculator. You have a million numbers. You can sort them properly. Very predictable. LLMs are much better at stuff that is less structured, summarizing an article, explaining something, translating, and so on. And they are both very bad at what the other does, okay? So we're going to try and combine these two worlds and try to make the best of these two worlds. So I think there's a cycle here that you use stuff with traditional software, you hand it off to an LLM, you get the result back to the traditional software, hand it off to the LLM, and go back and forth in a cycle that uses the best of both worlds. And now we're going to do one of them. So this is a prompt. Okay? Please create the JSON-LD script for this page, and there's this ugly HTML that you can throw at the LLM. Now, it will produce it for you, but it's much more likely to hallucinate because it has to parse the HTML, it's very complicated, you didn't specify anything. So how can we improve this? Well, we go back to the traditional software, so you can crawl a website with advertools with one line of code, and you can extract much more structured information from those pages, so you can, instead of throwing the HTML at it, you can give it structured stuff like, say, this is the title, this is the meta description, H1, H2, and so on. Okay? So now it's much less likely to hallucinate, and it's much more likely to come up with something more meaningful because we are giving it more clues. This is the title of the page, this is the body text, and so on. Now we can even improve this even further. We can do this. We can give it a more specific task to do. So we can tell it, this is a business event. This is the type that we want. And we want it to extract these properties, the name, the description, the start date. So now this becomes a trivial task for an LLM because it is all structured. It's very easy to look and see and find where the start date is and where the end date is. And it's very easy for it to create it in the good format for us. Okay? So this is the prompt that I used with the OpenAI AI API. Again, this is just a function. Client.chat.completions.create. This is a function that has these parameters. You just have to read what these are. We assign it to a variable. Completion equals name equals value. Same as before, it's just a longer kind of function, and we have some instructions to make sure that we give only JSON format in the answer. So now we get this, which is much less likely hallucinated stuff, higher quality and more structured because we gave it the structured data. And now this is what the LLM gave us. We can put it on the website. Obviously, you know what the value of JSON-LD is, but we can do more when we go back to traditional software, which is we can put these in a table like this, So we've converted this website into structured data and took it into a table. And now we can do something like look at one of the columns and, for example, the start date. And again, we can go back to traditional software and say, visualize this for me. Okay? So these are the events on the website of Search and Stuff. And we can see when the start date was. We see that there was a gap here, there was some pickup over here. And this is the kind of insight that you can get from this workflow. So the code for this is a bit more involved than the previous ones, but it's also included in the repo, and you can see it if you'd like to join tomorrow. So this is where we are here. See maybe next year. And yeah, this was a quick overview of what you can do. Thank you very much. If you're interested, you can get all the stuff from this URL. And thank you very much.
Thank you so much.